Okay, well, my project is on non-fossil oil to biodiesel, or fatty acid methyl esters, ethyl esters, or diesel as it became called in this class. My project differs from the other diesel projects in that I'm looking at flexible feeds such as coconut oil, palm oil, avocado oil, all sorts of options. You also have waste cooking oil streams, which can be cheaply obtained, and those just have high free fatty acid content, unlike the other feeds. And I'm also looking at how everything will be purified after the biodiesel is produced. What I've done so far is I have a potential process flow diagram of the entire process. I've so far found the feed costs on a bulk rate, and then the selling prices for the products produced. And then I have a complete material balance of the entire system done already for certain oil feeds. What still needs to be done? Everything needs to be sized. You know, the reactor needs to be sized, all the parts, distillation columns, sizing, all those. Just a lot of engineering work needs to be done. There's also some potential other processes that could be implemented. Instead of using water to remove the impurities from the diesel molecules, you can use magnesium silicate, which as a result you have no wastewater stream. So that's a green engineering benefit I was looking into. Another economic benefit would be converting the glycerol produced into propylene glycol. And by doing that, the selling price goes from $50 per liter to $500 per liter. So if it can be done cheaper than that difference, it might be a viable option. So the skills that are needed, you have kinetics and reactor design for the transesterification and esterification reactions taking place, which are going to differ based on oil feed and going to differ based on catalyst use, temperatures, everything. And you also have distillations, which is required for the purification of the diesel leaving. You have heat transfer for heating up things, and obviously mass and energy balance. So a lot of chemical engineering essentials are required. I believe my project should be kept because, one, I do believe it can be done this semester. I can find reaction kinetics data for the non-fossil feeds. Unlike some of the other diesel projects being looked at, it's hard to find reaction data for algae oil because it's not readily available yet. So using non-fossil oils, it's easier to find data as of now. There's a benefit to society if you could have a multi-feedstock diesel production plant. It's killing me. Multi-feedstock diesel production plant. You can change feedstocks based on cost in oil that changes day to day perhaps. If oil becomes more in demand, you can switch to another oil. Also, the economic benefit of using waste oil is considerably cheaper than using regular oil nowadays. So if you can have a plant that can use any sort of oil plus waste cooking oils, it's very economically viable. So does anybody have any questions?